talk a little bit at a higher level in terms of the industry changes that are happening and why people are adopting microservices, because what I hear when I speak to a lot of large enterprises is that it's a buzzword that they know they have to do, but they don't actually really understand why they're doing it. And they also try to implement things that are probably above their competency level. And we're going to talk a little bit about the broader industry changes and then dig into the things that are happening in the technology stacks to better monitor microservices. So I wanted to start out with a little bit of my background. I was a practitioner in IT operations for over 20 years, various companies from small startups to large enterprises. I was a research VP at Gartner for nearly 4 years before I joined AppDynamics. I have a lot of beliefs about how monitoring needs to change and evolve. Thankfully, we're starting to see a lot of that happen in open source now. And I'm going to go into some of the issues that we see, especially with these microservices architectures. But first, we have to understand this phenomenon of digital transformation a little bit. I have a couple slides to lay this out. What you find is that businesses realize now that if they don't become agile, if they don't become driven by software generally, then they will fall behind their counterparts. So people that are good at building agile software have great business advantages. You can look at some of the numbers here. These are standard numbers published by a lot of different research firms out there. But the biggest thing, aside from the potential opportunity to capture this new market, is also the fear that comes with it. And people realize that most consumers and most users in general aren't happy with the experiences that they have today. And people will abandon your site. They will abandon your applications if they don't perform well. And taking that fear to another level, if you look at all of your senior executives, is that the large industry giants that were not replaceable are being replaced. So the Fortune 500, the biggest companies in the world, are being disrupted by these other companies. So this is the fear that your CEO thinks about. You may think about things in a different level, but you still have to put it in perspective. So what we've seen is a big shift from traditional kind of back office systems. People used to spend a lot of time on ERP and CRM and big databases and data stores. And now everything is all about that engagement, the way that people interact with your software. It's the front ends, the user interfaces, the way that customers interact or your users interact. And that's where companies are now shifting all of their resources and spending, just so that you understand the shift that's happened over the last 5 years. These are numbers from Forrester. So breaking this down a little bit, everyone sort of assumes, I've listened to a lot of talks today, everyone kind of already assumes that you understand what microservices are. Okay, everyone understands it, but it's important to understand some of the nuances here, because there are concepts of microservices and mini services, and I actually haven't really heard anyone speak about this, so I'm going to kind of break down what sort of happened over the last 15 years or so. But first, some definitions. And you can see that there are various definitions. I'm not going to read them off. I think the reality here is a mix between it. From what Martin Fowler started out with, what Adrian Cocroft has kind of morphed this into, and then you can look at the general definition of the public by Wikipedia. But it's generally about decoupling and moving faster. These aren't really new concepts per se, but now we're starting to see software paradigms shift. So when you kind of look at the history of this, we used to have these big, complex, monolithic apps that we tried to break down with SOA. And that was the buzzword for 10 years, where people were trying to become service-oriented. And now you kind of see the next evolution of that, which is further decoupling. One of the pieces that you'll hear me talk about a little bit here is really where the data lives. And now you see things like services that don't necessarily contain their own data, or services that just manage data. And that's the big shift that went from an SOA type of approach to a microservices approach. But it's really about being able to move at different speeds for different parts of your app. But there are a lot of issues with this, let's say. The reason why people really want to move away from the monolithic apps is to make it easier for developers to really own the entire life cycle of their particular component, and to make it easier and faster to get up to speed so that they can get involved in a project faster, iterate faster. It also makes it easier to manage development environments, both on your machines and in general, the shared environments. And there's a few other things here, but it's about avoiding lock-in, because as you're moving quickly, you need to adopt new languages, new data stores, new technologies. So it's about moving quickly. And it's really about that flexibility, and that there isn't dependencies on the subcomponents. So building nested hierarchies in your services creates single points of failure and other types of problems. In enterprises that I speak to regularly, they don't understand a lot of these concepts, and they create microservices architectures that are less redundant because of the way that they design them. So it's important to understand this decoupling and understand that it's really about the choice of your teams, what technology to use. A lot of people will try to standardize on Cassandra or standardize on MongoDB or standardize on data stores, and that is not really what the fundamentals of microservices are, which is a choice of language, a choice of technology. And the idea is that you replace these quickly. So if someone wants to write a new service in Node or in Go, and you're a Java shop, there should be no reason to not allow them to do that, as long as they own the life cycle of that service and it's segregated away from the rest of the app. So a few examples. This is an e-commerce kind of example of what typical microservices may be. A lot of people will try to break these down into too small of a subcomponent, and then you create performance issues because of the chattiness between the different pieces. So it's important to have the right size microservice and not think that you have to build, for example, my user profile. I don't need photo upload that's independent from the other components that are part of that service. It should be big enough, but not too big. And there's lots of books and material on how you actually pick the size of your services. And it's an important thing to consider when you're going down this path. So some other reasons people shift are because of organizational changes. Most of us probably practice DevOps, but when you look at monolithic systems, especially in enterprises, this is typically what you see, where you have a networking expert, a database expert, a Java expert, middleware experts. And Conway's Law says that if you organize your people in your applications, your people in that way, your applications will mirror that. So what this means is that if you build monolithic teams, you will end up with monolithic applications. And those of you that are in larger enterprises, the challenge here is that it's really hard to change this. So what you see a lot of organizations doing is creating a legacy team that looks more like this to manage legacy apps, and on top of it, creating a more agile team that works a lot more in microservices or DevOps. So if we want our teams to work together, and we want the network team and the database team and the server team, the other infrastructure teams and the developers to be in small, tightly grouped teams, we have to look at our applications to mirror that type of organization. So these two things need to actually work together in order for this to work. And that's really what microservices does, is it breaks down the large application into little pieces. Now, it comes with a lot of additional challenges, and this is the thing that most enterprises don't consider. A lot of them still have centralized data repositories, but they're trying to do microservices. The problem that you run into is that the schemas and the way that this is architected and designed is rigid, and your teams are trying to be agile. So if you have a centralized data repository, probably that's relational, you're going to have a really hard time doing real microservices. But people don't realize that this data architecture shift is probably one of the hardest things that you're going to have to do. So the idea here is that the data needs to be paired with the service that is responsible for, so that I can change my data store, I can update my data store independently of what the other teams are doing. Now this creates a lot of challenges like consistency. You have to replicate the same type of data across your different services, which means you have to create messaging layers and all kinds of other things to replicate that. And this is hard to do well, and it's hard to manage consistency. You know, which copy of that data is the most accurate. It probably doesn't matter as much if you're running a solution like Facebook or something that's social media, because if the data is slightly out of date, it's not going to be a problem. But if it's your bank, you need to have that consistency ensured. So that's the challenge with these architectures, is that they don't fit all the business models. So you end up seeing a hybrid between the two occurring, and I'm going to talk a little bit about that. Similarly, if the teams want to pick their own technology, as long as the data consistency and the replication can occur, which is done with back-end messaging and other software in between the components, and decoupling the data access from the actual application itself, then you can actually pick what types of technologies and change these quickly. So that's kind of, those are the keys. And what you end up with is you end up with these new types of architectures, and there are different patterns that you see in traditional applications and what we call web scale applications or microservices applications, where the languages and components are smaller, they're easier to replace, less monolithic, more open in general, less tied to a vendor. And these are some examples of what you see in both. So if you believe that you're building a microservices architecture and your architecture matches too many of these on the left, you're probably not. But that's not necessarily a bad thing. So there's a lot of challenges here because you have to deal with automation, you have to deal with culture. There's a lot of issues when you're building these microservices that don't exist in the monolithic systems. These are hard problems to solve, and a lot of folks don't have the right skills to solve these. So it's about education and bringing the best talent for each of these individual challenges together. So a lot of this is really the culture and organization to make you overcome these challenges, depending on how complex your app is. Now, there's also another thing that kind of has started to be talked about by folks like Gartner in the last 6 months or so, which is this idea of a mini service. And what this is basically a way to take SOA and make it not as bad as it turned out to be. So you can deal with which APIs are you using inside your app and which ones are you using between your apps. And these mini services don't require things like the data being coupled with the service. You can still have centralized data, but surround it by an API so that it's more flexible and people aren't directly accessing data stores. That's an example of why people are kind of hybridizing microservices and using this concept of mini service, because it's less of a jump. So for a large enterprise, or if you have a large monolithic app you can't change, this is often the right kind of pattern that you should go after because it's attainable and it's not such a big jump. Those of you in startups with a clean slate, you don't have this problem. But many of the folks I've spoken to today definitely still have legacy systems and modern systems that they have to deal with. So what does this mean for performance in general? First, we're going to just take a look at some stats around Docker and how it deals with performance. And then we're going to talk about the challenges. Everyone kind of approaches this slightly differently. How many layers of virtualization do you want to manage? Those that are running bare metal and can run like something like Koros with native Docker, it's less complex. But in enterprises, they have big investments in traditional virtualization like VMware, and you still want the flexibility of Docker. This creates a lot of different layers that need to be managed, and it's a big challenge for enterprises because it just starts to create additional complexity in how you manage and monitor your applications. So you really have to consider whether you have a clean slate or whether you're coming into an environment where there's already big investments in virtualization. So containers are obviously much smaller. They're easier to package. They're easier to manage in general. And they launch much more quickly so that you can do things like orchestration, which was talked about earlier today. These are kind of a few of the advantages that people generally see when they move to containers. But it's also important to take a look at the differences between bare metal and containers in terms of the actual raw performance. So I'm going to actually put up a few things around kind of the performance itself and how something like KVM compares to something like Docker. So for certain types of things like boot time, they're relatively equivalent to each other. There's not a lot of advantage per se. But when you look at things like reboots, Docker's much faster because it doesn't need to initialize all the subsystems. So if you need to reboot something or reconfigure something, much faster in Docker, and you can see a big performance difference. And similarly, when you get down into the actual subsystems themselves, memory, for example, is much faster in Docker in terms of memory I/O. So if you're doing a lot of in-memory computing, or if you're running an in-memory data store, Docker is essentially going to be the same performance as you would get in bare metal, much better than putting a hypervisor in. So if you have the choice of having that extra layer of virtualization, you don't want it there because it's going to just add overhead to your application. There are also other things that Docker is not as good at. For example, disk I/O. Docker, and I don't have slides up for that, but Docker is generally not as good in general for disk, but CPU, network, memory, you're going to see almost the same performance characteristics as metal. So it gives you a lot of the advantages and flexibility without sacrificing the performance. And when you look at hypervisors, they definitely do have sacrifices in the performance side. So now we're going to touch on monitoring a little bit, what the state is, what's going on in monitoring in general, and some of the challenges. So I'm a strong believer in transaction tracing, which is something that it's finally starting to emerge in the open source world. But when you think about your users, they run a transaction, like I'm logging into a mobile app or I'm logging into a web app. And it traverses all of these different components. And this is more of like a traditional application view. Realistically, our applications kind of look like this, where we have all these different components and technologies that have been layered on top of other components. And when you see new paradigms like IoT coming into the picture here, it just creates a lot of complexity. So when you're troubleshooting, the biggest problem is trying to figure out where did that transaction go? Why is it running slowly or failing? And where is the problem? So tracing from end to end is a key tenet. And in application performance monitoring, the technologies, it's all about this transaction tracing. I'm going to talk a little bit about how that's evolving in open source. There's been great strides made in the last 6 months. And I think we're finally going to see some good transaction tracing. So, I'm losing my mic. There we go. So I wanted to talk a little bit about a few of the options in open source today. You'll typically find that you need a combination of these technologies. So cAdvisor is kind of the native Docker container metric engine. And now a lot of tools can pull data from that, and it can be embedded in a lot of the implementations. But it comes at the Docker layer, gives you metric access to Docker itself. When you actually look at the logs, you're getting logs from the containers, you're getting logs from the hosts themselves, and you're getting logs from the applications. Guys like Elastic, which you can see here, they're exhibiting, I saw, they have a stack, but it has a lot of different moving parts to it, both from the way that data is collected, stored, and the way that you visualize it. So their stack consists of the 3 components, which is what Elk comes from. And then there's a lot of other infrastructure monitoring tools. There's sort of the old guard, I would say the Nagios and even Sensu at this point. But I think Prometheus is doing probably the next generation of this, but it adds a lot of complexity because you still need to manage Elk, and you have to manage your metric engine as well. So it doesn't do any type of transaction tracing. This is all metrics and logs, and those are great and they're important, but they don't give me any visibility back to my user, and they don't provide me with pinpoint accuracy where transactions are stalling or failing. So thankfully, there's been some advances going on in the past year or so. Adrian Cocroft started this really cool, and I talked to him quite a bit, and he's big into the transaction tracing concept, and he created this visualization layer where you can basically feed it XML data and it'll visualize your environment. So this is more like a topology or like a graph showing where your application is going. And he started actually now feeding this transaction data, and you can kind of start to see transaction tracing visualized the right way. The other piece is Twitter started this project called Zipkin, which has been around for several years, but was sort of a neglected open source project where they put it out there and expected people to build on it. And no one really did until last year when they actually split it out and gave it to a foundation, and it actually started getting developed much more significantly. So it was renamed OpenZipkin, and now you're seeing actually a lot of development, new adapters, new ways to trace. And you can see in these 2 examples is it kind of gives you the visibility of a stack trace as your application traverses the different components. And although the visualization's kind of ugly, it at least gives you some kind of visualization so you can understand where your application is going as it communicates. So with this, they actually have agents that will plug in, so you can write your own instrumentation. So if you're using something like Go or Python or PHP or Java, you can write this in your code, and they also have agents that can plug in and they'll trace it for you. So the idea is when it goes from one server to another, it creates the traceability back to it. And this is kind of similar to what commercial APM products do. And I'm gonna kind of get into that a little bit. But the idea here is that when I have a microservices architecture with a bunch of different pieces, I can isolate where the latency is coming from. And then I can escalate it to the right team saying, this transaction is having latency because of this service, and I know the service owner. So it makes that isolation faster. The other thing with Zipkin is it's not always on, so you can turn it on and off, because anytime you collect data, there's overhead in your application. Because these are sitting in the transaction path, when you're tracing, there is overhead, but it's usually really low if you do it the right way. But like most open source projects, you can hang yourself. So earlier today, in the Prometheus talk, I asked about polling. How often do you poll it to pull data? 30 seconds is normal. But if you want to poll it really too often, if you were polling it every half a second, you would create a performance issue because you're over collecting data. With tracing, it actually is even worse because you're sitting inside the app versus sitting on top of the app collecting data that already exists. So with tracing, you have to be careful with the overhead that you introduce. And there's a lot of debates about that. There's also this new project, which a bunch of guys from Google have started, called Open Tracing. And they're trying to create an open API for doing this type of transaction tracing, which in the past has been relatively proprietary. There's a new stealth startup, actually, that is kind of behind this, that is an APM company. And they've created a bunch of different handlers where you can embed this open tracing. And the idea is this exposes APIs that you can then plug into other tools. So I'm estimating that this, coupled with the things that are happening in Zipkin, are going to create a much more comprehensive tracing capability in open source. But this has all happened in the last year. And I think it's probably another year off before this turns into something like a more consistent, cohesive product, an open source project. But once again, this doesn't look at end user experience. It's not tracing into the browser. It's not tracing into the mobile device. Those are things that still need to evolve in this technology stack. So when you look at commercial tools, there are lots of options out there to do the same kind of thing. Most people will combine APM, log, and infrastructure monitoring tools. These are kind of examples of commercial tools. At AppDynamics, we build this all together that does infrastructure, logs, tracing, end user experience. So we believe in kind of unifying this and trying to create a consistent interface. This isn't an AppDynamics ad, but that's our goal as a company, is we want to do all of this versus having you have to switch between consoles and tools and views. I mean, that's our goal, is to simplify it. So we do this really cool kind of transaction tracing for everything that visualizes from the browser all the way down to the database. I hope in open source it gets somewhere near this point where you can actually isolate problems, you can see end-to-end paths and do so with low overhead, but it doesn't exist yet. And then I'm hoping Docker monitoring starts to look more like this, where you see groups of nodes and it gets visualized in a kind of easier to digest way than a bunch of metrics and a bunch of charts and graphs like how we deal with data today in most of the tools. So I'm also going to talk, this is a bit more about the silos in the enterprises. I wanted to kind of put this into perspective so that you can understand why it's so difficult to troubleshoot today. Every time there's a new technology, whether it's Docker or VMware, new storage system, new database technology, you're introducing Cassandra or HDFS, it comes with a new wrench, a new tool. So our toolboxes kind of look like this, where we have all these tools and different teams decide what tools they want to use. So everyone's kind of working from a different page because it's all segmented. And every time you add new technology, you add new monitoring. And it's kind of unfortunate, but it turns into a mess. So each of the teams, both in the technology and the team itself, picks different tools, and they have different views. So what ends up happening is that people get attached to their tools. My video doesn't play. People get attached to their tools and they never want to let them go. So once you put in Nagios, there's a team that loves it. And you say, oh, we have this new thing, it's way better. Nagios is horrible to manage, everyone agrees with it. Well, I've customized it and it does what I need it to do and I'm happy with it, so you're never gonna take it away from me. It's my tool, I've been doing it for a decade, and I don't want to change. And this happens all the time with new technologies, is that people never want to let go of the technology that they're comfortable with. So you end up with not only a proliferation of technologies themselves, but a lot of overlapping tools, and there isn't context between them. So this is kind of the problem that you run into with a lot of the open source that does a little piece of this, is that when the user complains, you know, my checkout transaction is slow, you don't really know where it is. Is it a network problem? Is it a server problem? Is it an app problem? Is it a CDN problem? Is it something else? And so when you isolate problems, you end up with these escalations where a couple people will talk, a couple more people will talk, and before you know it, you have this like huge meeting with half of your team at the company trying to figure out where the problem is. And it's really because no one understands what's happening from end to end, and everyone's looking at their own little lens of what they're responsible for. So, I mean, these are the common problems that, and lots of you are laughing because you're probably like, yeah, I did this last weekend instead of enjoying my weekend. But yeah, it's unfortunate. So it's about finding that context and getting consistency in the way that you instrument, in the way that you look at your apps. So these are, it's about sharing information and context. And so monitoring, instead of us always looking at infrastructure, which is one of the core things that we look at, we should flip that around, and we should look at our customers and our users and the applications they use and the infrastructure it sits on. But instead, we tend to do things the opposite way. We look at the infrastructure first and the user last, which doesn't really make any sense. So I believe that it needs to be user first, and that tracing is key to understanding that application piece, and that the infrastructure comes after that. Because if you don't understand the relationships between those pieces, it's going to be hard for you to isolate problems. It's going to be hard for you to be user-centric. And that's, these are kind of the fundamental issues that I see in monitoring today that need to be fixed. But there's a lot of good progress being made. So I'm going to open it up for questions or comments. You can tell me I'm full of it. Anyone? Questions, comments? Come on, someone has to have one. No? All right. Oh, one over here. Sure. Sure. This one or, oh, okay. Sure.
So the silos.
Yeah.
Practically, I would say this is what the whole DevOps movement, actually tries to deal with, that we don't have these silos.
Correct.
I mean,
I
think this is the problem of like the last 10 years, that we have silos, and we said, so I'm application developer, I care about the application, and that's it.
Yeah.
Or, and that's just a comment that maybe we should just like approach it from that direction, that we should like break down the silos altogether.
That's true, but in large environments, you still need a dedicated team. So even in a lot of the companies and the folks that I've spoken to today, oh, sorry about that, they still have those teams. So I don't want to call anyone out specifically, but there's a lot of folks that I've spoken to today that are in DevOps, but they say, oh, I have a traffic engineering team that does that. Because I ask about delivery or user experience, and oh, the business looks at the user experience. We manage the infrastructure and the apps. And I'm like, well, isn't the user experience the most important piece of your business? And isn't that what the apps are being used for, to service your users? But very few people that I've spoken to here that do DevOps are user aligned. So I mean, how can you possibly say that you're doing the things the business needs when the business needs that transaction to work? And so that's the problem that I see even with DevOps, is that sure, it brings development and operations together, but it doesn't align it to the business. And that is what I think needs to change. So, anyone else? Thanks for the comment. All right, well, that is it. Thank you very much.